Hello viewers, today's topic is about high voltage system on ship. So what are the advantages of using HV systems on ship? What is the voltage ranges, typical voltage ranges we have on board ship for HV system? And what are the switch gears, what type of current ratings we are designing the switch gears? And what are the safety measures has to be taken for high voltage system? So this is the topic, today's lecture topic. We'll go for the next slide. So generally, the voltage what we use on board ship is usually three-phase, 440 volt, 60 hertz is being generated and distributed. So for a three-phase, it is 440, 60 hertz voltage is being generated and distributed. But nowadays, the owner of the ship go for a bigger ship to get more profitable. So bigger ship cargo charging and discharging, the imports and exports can be more as compared to small ship. So SOx, NOx pollution can also be reduced and efficiency of the fuel can be more. So these are all the reasons why the owners go for a bigger ship. So for a bigger ship, we require powerful engines and machineries like high power bow thruster electric motors. So HV electric motors are used for compressors, for propulsion converters, and reefer container ships, for cargo cooling machineries in gas carriers. So these are the requirements for HV machineries on board ship. So this is the general thing why we go for HV system. Even though we have a lot of advantages of HV system, some of the disadvantages was also there. So how to overcome it and how to protect. So that is the topic, today's topic of HV system. So in marine practice, majority of the merchant ships have a three-phase, three-wire, 440 volt insulated neutral earth power systems. Normally what we have the three-phase, three-wire 440 insulated. It is a insulated neutral system. So this power system falls in the category of low voltage and meets the power demand of medium capacity motors up to 200 kilowatts. For bigger ships, 1000 voltage, more than 1000 voltage, above 1000 voltage is called as the HV system in marine practice. In marine, we say more than 1000 voltage is called as an HV system. So typical marine high voltage system voltages are 3.3 kV, 6.6 kV, and 11 kV. It is 3.3 kV, 6.6, 11 kV. These are container ships, some LNG gas carriers, and cruise liners, and fuel and oil production ships. So this type of ships requires more voltage. So that is coming under the HV system, 3.3 kV, 6.6 kV, and 11 kV. So these are the typical marine HV system voltages we have. So this slide is about design benefits of high voltage on ships. So what is the benefits of HV system according to the design, according to our electrical formula? What is the design? Is actually we have the Ohm's law formula. The Ohm's law is power is equal to V into I. Power is equal to product of voltage and current. Power is unaltered. Power is generated. Power is distributed. But we can change the voltage by using this step down or step up transformers. We can change the voltage. So whenever we change the voltage, the other product current will also change. When voltage is increased, the current will reduce. That is the uh, uh, definition from this, finding out from this high voltage system. That's what we want to know about that. Power is equal to V into I. When voltage is increased, current has to come down. So that gives the product of power. Power is unaltered. We cannot change the power. So your first point, for example, I'm taking ship generator produces 2 megawatts, 2 megawatts of power. Can use this. So it is using 2 megawatts of power. This power is equal to root 3 VI cos pi. This is our formula for power. From this, I'm going to find out what is the full load current I value. So I is equal to power divided by voltage, that is power divided by power is 2 megawatts, 2 into 10 to the power of 6 divided by root 3. I'm using voltage 440 volt. So cos by 0.8 I'm using all inductive loads, motors. So we use 0.8 as a perfect. So the current value, the full load current value, what I get is 3280.5 amperes. So approximately I can say 3300 amperes. So this 440 voltage, now I am stepping up to 6600 voltage. This is high voltage, 6.6 kV. This is high voltage. So when 440 is being stepped up to 6600 voltage, and what is the current value is, the calculated current value is 220 amperes approximately. I'm saying approximately, it is 220 amperes. So from 3300, the current value has come down to 220. So we can see the change. We can see the difference between 3300 to 200. So this much times the current is getting reduced since we raised the voltage from 440 to 660. But the power is same. The power what we use here is 2 megawatts. Here also 2 megawatts, 2 into 10 to the power of 6. What we are using, the power is same. Only I am stepping up the voltage according to the current is getting reduced. Now, what is the advantages of reduced current is, conductor size is getting reduced. The current is carried through a cable. So that conductor size is getting reduced. So when the size is getting reduced, it means that reduced copper requirement. Whatever it is hanging over, whatever the switch gears, what we are using, whatever the stainless steel material, whatever the conductor is carried through, everything is coming in low cost because the size is getting reduced. So the weight is getting reduced. So the cost is getting reduced. This is the biggest advantage we can say. So next advantage is, since we take copper loss, or we say it as a power loss. So power loss is equal to I square R loss. So here I have shown the formula, I square R loss. So current is reduced from 3300 to 200, the current is reduced. So the square of the current will also get reduced. That is the loss. I square R means square of the current. So the current is getting reduced, the loss will obviously will get reduced. Simple calculation. So when compared to low voltage system, as the current flow is less. So when we go for HV system, the major two advantages what we are seeing from this slide is, when the voltage is stepped up from 440 voltage to 6600 volt, voltage being increased from 440 to 6600 volt, the current is getting reduced from 3300 to 218 amps. So we see the change. A vast difference is there and it is getting reduced. And because of this reduction, the conductor sizes are reduced and cost is getting reduced. So this is the main advantage. And the losses is also getting reduced. I square R, square of the current. Current is reduced. Losses is also reduced. So that is the major advantage. We'll move to the next slide. Yeah. So also a motor, let us assume a both thruster may be of a smaller size. The equipment size, the machinery size is also getting reduced because of high voltage. So whatever the machineries we are using, HV motors, so these sizes are getting reduced for the same power. Power what we are using is same, but since we are increasing the voltage, we are reducing the size. The motor would be of a smaller size. So I have marked it here. So it is of a smaller size when it is designed for 6600 volt when compared to 440 volt. So high voltage machineries have reduced size and weight. So this will increase the space for cargo. And again, this is profitable for the owners. So owners will see for their profit. So when we go for a bigger ship, the first point in the introduction, we saw that more cargoes can be imported and exported. And we can reduce the SOx, NOx pollution problems. Fuel efficiency is good. Here, one more thing, what we are saying is the machinery sizes are reduced and we have more space for the cargoes. Again, we can take more cargoes, that is more profitable to the owners. So each generator and feeder cable requires. So whenever we connect a generator, the generator should have switch gears, protecting devices, circuit breakers, and the feeder cable distribution side also, there will be a circuit breaker. So how to design this circuit breaker? For 440 voltage, we are designing the circuit breaker, which is approximately 90,000 amperes. So for short circuit current, for any fault current, we have to design the circuit breaker. So the designing of the circuit breaker is 90,000 amps for 440. So because it depends upon the current rating. Again, the current is getting reduced. So the protecting devices approximately their values is also getting reduced. So when we calculate for 6,600 volt, this is for HV system, the circuit breaker is designed for 9,000 amperes only. So previously it is for 90,000. Now it has become 9,000 amperes circuit breaker is designed. So the machinery sizes is being reduced and the switch gears and protecting devices is also current ratings is designed to be reduced. Their sizes will be also less. So these are the advantages we see from this slide. Next, we'll go for the, hope you understood up to here. Next, we go for the next slide. High voltage equipments. So what are all the equipments which is present on board? Generating sets, high voltage switchboards with associated switch gears, protection devices, and instrumentation. High voltage switchboards with associated switchgear, protecting devices, and the instrumentation. Whatever the MSB boards we have, the switchgear protections, everything, it is designed for HV system, and the instrumentation also. So suppose if I am using insulation resistance, if I am using for 440 voltage, I can use a megger like a hand driven megger or something like that. So if it is for more voltage, I cannot use hand driven megger. Hand driven megger, a crankshaft will be there. I have to rotate it. Inside generators will produce some 500 voltages. So that cannot be used for HV system. So we have to go for battery operated megger. So many instruments has to be changed because of this HV. So according to that insulation, the protection devices and instrumentation should be changed in the switchboard. So these are HV equipments, we say like that, and high voltage cables. The cables insulation and these things also will get differ. High voltage, low voltage, step down transformers to service low voltage consumers. So we have to need the requirement of transformers. So for suppose if we have lighting system that is for 220 volt or something, then we have to step down it. So machinery is what we use for very powerful engines and propellant. For these things, we have to go for HV. And for low voltage applications, we have to go for step down transformer. So that type of equipment is also required. High voltage to high voltage, 6.6 to 2.9 kV step down transformers is also used for propulsion converters and motors. So compressors type of motors and air conditioning compressors, for these things we require 6.6 kV to 2.9 kV. So that type of transformers should be also present. So these are all general HV equipments which are present on board ship. So we'll move to the next slide. So I'm just shown the images of HV cable, how the cable is look, and I've shown the HV motor here. So we have a high voltage motor, electrical motor for the propeller. So this is a HV motor is what connected, just for showing the image. The major difference between a high voltage supply and low voltage supply on board ship. So what is the difference between using HV and LV? High voltage systems are more extensive with a complex network and connections. With complex networks and connections, isolated equipment must be earthed down. So whenever we isolate the equipment, since it is a high voltage system, the insulation is also different. So when we do insulation, according to that insulation, the capacitance values will increase. High insulation, the capacitance value will also become high, insulated capacitors. So since the capacitance values are getting increased, energy stored will be also increased. Even though if you put off the power supply, such equipments and cables will have energization inside. So it is very much required to earth down the isolated equipments immediately. So whenever whatever the voltage is present inside that, that has to be dissipated out, that has to be discharged immediately. So that's it is given isolated equipment must be earthed down. Since we are using HV system, insulation is high and the capacitance value is high. Due to high capacitance value, energy storage is also high. So that is the reason why we earth down. Access to high voltage area should be strictly limited and controlled. So that is limited areas as you have to move along. Isolation procedures are more involved. Switching strategies should be formulated and recorded. Switching strategy. So what do you mean by this switching strategies? Those times there will be a manually operated switching systems, how to connect open circuit breaker, closed circuit breaker, earthings, and these things has to be done manually. Nowadays, it is automatically done. The electronic devices will find out what is the desired output value, what is the output voltage is required. According to that, the switching strategies can be changed. The switching circuit breakers and these things can be changed automatically, and that has to be formulated and recorded. So at a routine basis, this has to be recorded. So basic high voltage test probes and instruments must be used. So we cannot use the instruments and probes which is already used for low voltage application. This is different instruments. Diagnostic insulation resistant testing is necessary. So IR value has to be tested. Insulation is very much important in this case. On all the cases when insulation fails, it starts heated up and it starts burn. So this is very important. High voltage systems are usually earth neutral and use current. Limiting resistors, special high voltage circuit breakers have to be installed. Special high voltage circuit breakers have to be installed. So this image is what I'm shown. So all our clamps are connected together and it is earthed in a common earth connector for up to 11 kV. So this is an image shown, and this side is automatic operation of the switching devices, that is switching strategy. So how the switching systems are done. So this is Megger, the Megger which is used for HV system. As I have already said, 500 volt type of Meggers, we have both the cases of 500 type. One is the hand driven crankshaft movement of Megger, and one is battery operated. But for a HV system, we cannot go for hand driven Meggers. So we cannot drive it, that may be too heavy, and generator which is used to produce a very high voltage, suppose 2000 volt or 3000. Just HV means we require high voltage. So those conditions we cannot use generator to produce a high voltage. So we have to go for battery operated. And this image is showing about the this is earthing rods. So these are the earthing rods that is used for earth. So that is used to dissipate whatever the fault current or discharge the energy stored currents and these things. So this is earthing rod, which is used for earthing. And what are the disadvantages of using HV system? Danger of electrical arcing, arc flash, arc blast. So what do you mean by this arcing system is electrical discharge. So whenever there is an insulation failure, conductor failure, the electrons will try to jump from one contact to other contact. There may be insulation failure in between the two contacts. So these electrons will try to jump from one contact to other contact. This will create some sparks. So when it is trying to jump, it takes the medium of this air as a medium. So that is arcing. So when this develops, and this may happen up to arc flash and arc blast. So arc blast will produce intense amount of light, heat is produced, and sound is also produced, and this may go up to some 20,000 degrees centigrade of heat. Very high heat it produces. It's very highly danger for this arcing. So we must check the insulation levels. If we have a good insulation, we can avoid this type of arcing problems. So danger of electrical arcing, arc flash, arc blast. So that heat and density of heat and temperature is very high in arc blast. Sparking in the air. So normally when we walk across the HV lines, long transmission high voltage line, we can hear some hissing noise. We can hear some noise that is because of that energization of ionization of the cables in and around the cable is getting ionized. So that is because of high voltage. As I said, the capacitance value will get increased in HV. So that will have a lot of storage inside that. Energy storage will be there. So that may create sparks and these things if proper insulation is not done. So these are the disadvantages. For the safety reasons. We have to be very conscious about this. Higher class insulation is required for conductors, cables, equipment used in the system. Generally F class, we say generally F class and above, that has to be done for the insulation. Insulation, we have different types of insulation for cable insulation, polyethylene, butyl rubbers, old version. And here we go for F class type of insulation for high voltage system. Skilled labor required for handling HV system. So the person who is experienced with the HV connections, who is experienced with the installation of HV systems and maintenance, the particular person has to work with the proper work permit and other necessary actions, whatever is. Safety is first, whatever we speak. So higher risk factor and the necessity for strict adherence to straighten the safety procedures. So the main disadvantages, it is the risk factor. So we have to follow the safety procedures properly. So special switch gears are required. So whatever the switch gears what we are using before, that cannot be used. We have to design it for our current rating. So the variation of current is present. So according to that, the switch gear short circuit current, we have to design the switch gears. So this is the symbol of HV warning notice. So this we can can be placed in HV systems. Wherever we can place it and show like a danger symbol. Thank you for listening to the lecture. If any doubts, you can just put it in the comment box. Thank you.